Professor Belfrost's computer science class is back!
Hi everyone, I'm Professor Belfrost and today I will bring you another new tutorial because now we have computer science class with me again, Professor Belfrost. So in this series of tutorial, I will discuss about basic to advanced concepts of computer science, also programming and coding in languages like C and C++, Python, Java, and any web programming, both front end and back end. But yeah, we start from the basic first, yeah, and then we move to the practice, I mean the programming. So today I will just explain to you about the basic of computer science. And I think the basic of computer science will span through maybe not only this video, but uh, the next 3 or 4 videos will also discuss about the introduction of computer science. So are you ready? Ready, set, go. Okay, so introduction to computer. So when we discuss about computer science, the first thing that we really need to understand is what is actually computer? Is my smartphone a computer too? Actually, what kind of criteria that define or yeah that distinguish a computer to any other machine? So let's see the definition of computers that given by some experts on this subject. Okay. Oh, first we will dive into the general concept, general notion that the term computer originates from the Latin word computere, meaning to calculate or to reckon. So computere means to calculate or to reckon. So at first time, a computer actually only refers to um, individuals who perform mathematical calculation manually. So yeah, just basically just calculator. Okay, but over time, this definition have evolved to describe electronic devices that capable of processing, storing, and manipulating data according to program instruction. So the very important concept of computer is that computer is just a machine that understands specific kind of rules or instructions that has been programmed before. So we just give instruction, and this machine will execute it uh, sequentially. That's just what's called computer. So let's see the definition of computers given by 10 experts that I have summarized for you. But you can find out more. But I think that this 10 is enough. I will just dive into the most important one. You see that I have underlined it for you. Alan Turing, sequence of operation in accordance with a predetermined set of instructions. Then John von Neumann, a device that processes data according to the set of instructions stored internally. Then Donut, a tool for solving problems, processing data, and performing calculations with speed and accuracy. Then we have what again? Yeah, um, Ada Lovelace, yeah. It's not a merely calculator, but a universal machine capable of performing any task that can be expressed in symbols and rules. Yeah. So actually, yeah, I think maybe that's enough for us to summarize what actually a computer means. So a computer is just an electronic device that designed to receive, process, store, and output data in certain way. So it operates based on a set of instructions known as program or software. But actually, this program is just a set of instructions, yeah, which dictate its behavior and functionalities. So you use Microsoft PowerPoint, you use Microsoft Word, you use Adobe Photoshop, Adobe Illustrator, you use Figma, you use what? OBS Studio. Actually, this is all just software that works on certain instructions, a certain set of instructions that can be called functions. Yeah. So yeah, computer also has history. Yeah, so computer evolves. Yeah, the first machine, calculating machine, is called abacus. Yeah, abacus. That means calculating board. Yeah, which have horizontal bars with sets of bits. Okay, then we also have Napier's bone, which is a mechanical device built for multiplication by John Napier. Then we have slide rule that developed by Edmund Gunter that use slide rule to perform addition, subtraction, multiplication, and division. I didn't insert the picture, but you can search online. Then we have Pascal machine for adding and subtraction. We also have Leibniz multiplication dividing machine. We have punch card system, yeah, that was developed by Jacquard, yeah, to control the power loom in 1801. Okay, so actually this punch card is the fundamental of a digital system that we know now because it works using binary system 0 and 1. Okay, and then Babbage analytical engine, and then Hollerith punch card. Yeah, Hollerith punch card is just another upgraded version from Jaguar punch card. Okay, so that's all. I think I didn't need to give you a very complete story. You can just browse Google for more information about it. Yeah, we'll go directly to computers generation. Yeah, computer in the meaning of that. Yeah, it looks like it resembles the functionality and the appearance of what we say to be a computer in today's life. Okay, so the first generations about 1940 to 1956, yeah, it used vacuum tubes. Yeah, vacuum tubes actually generate a lot of heat. So actually we have a huge, yeah, we have a huge power loss here. Okay, and it consumes a great deal of electricity. Yeah. Also, this machine prone to malfunctioning and require constant maintenance. Okay, and it is very difficult to program because it uses machine language. Yeah, we haven't invented programming language such today. Yeah, even like assembly language hasn't been uh, invented at the time. Okay, the computation time is about milliseconds, yeah, quite fast, but not as fast. And the physical, yeah, it requires enormous room for installation, and yeah, there are many kind, Unifact, ENIAC, EDFAC. You can just browse for the picture. I'll not show you here. Okay, the second generation is transistor. So actually, what is transistor? I will show you the picture. This is transistors. Yeah, we still use it today. Yeah. I also teach robotics and electronics, so I use quite often this kind of tools. Okay, so uh, this transistor makes us become easier because it is smaller, faster, and here we have introduced what called assembly language, yeah, which uses mnemonic instead of just machine language. The computation time is microseconds, yeah, and we have shrink the size a little. Okay, maybe you can read it. You can just pause the video if you want to read it for a longer time. And then the third generation, we use integrated circuit. Integrated circuit as the picture shown in the slide. Okay, on the slide. Okay, so actually, I see just a chip that consists of multiple transistors that placed on a silicon chip. Silicon is just kind of semiconductor. I think I will explain to you about in robotics class. Okay. So with the use of IC chip, we have increased the speed and the efficiency of computer. Okay. And when the third generation came to existence, we have already been introduced high-level languages. Okay, to replace machine language and assembly language. And the computation now become nanoseconds, and it has been quite accessible by mass of audience. Then the fourth generation using microprocessor, and then yeah, you use LSI and VLSI technology that thousands or even hundred thousands of transistors are integrated in such small silicon chip. Okay, so also you can yeah, just read the text on the slides. I'll not explain it to you. And this time we already reduced the computation time from nanosecond before to picoseconds. Okay, and yeah, nothing very important here. And nowadays we have fifth generation. The main difference between the fourth and the fifth generation that we have integrated AI. Okay, and here you have computer with you now. Yeah, computer is very important in now digital life. So actually have some classification on computer. We have microcomputers, we have mini computers, we have mini computers, we have supercomputers. Okay, so you can see this is the picture of the computers that I say. Okay, so first we have microcomputers. What is categorized as microcomputers is your desktop, your laptop, your netbook, your tablet computer, your handheld computer, PDA, personal digital assistant, and your smartphone. I think everyone has smartphone. Okay, so microcomputers are small, low-cost single user. It consists of CPU, input-output unit, storage unit, and software. It can be connected together to form a network. Okay, and then many computers, yeah, it can be used for multi-user system, has high processing speed and high storage capacity, and can support from 4 to 200 users simultaneously. And then we have mainframe computers. Also, it is new to user, but it has higher performance and can handle workload of many users. And it generally used in centralized database. Users can access via terminal, dumb, or intelligent. Yeah? Your exercise now is to find out what actually mean by dumb terminal and intelligent terminal. The next one is supercomputer. It's very fast and the most expensive one, and the processing speed measured in flops. Yeah, flops. So FLOPS. Yeah, floating point operating per second. It used for highly calculation-intensive tasks and for major universities, for military purposes, and scientific research laboratories. Yeah. There are some important terminologies. I want you to take a screenshot of this and find more information about this because I will explain it in the next video. Okay? Yeah. Okay. So also in the next video, I will focus on this computer's component. So we have CPU, we have memory, we have storage device, we have input device, and we have output device. So also I want you to take a screenshot first about this and then find by yourself for more information about this before I start the class on the next week. Okay, and find the difference between memory and storage device. Also, what mean by volatile and non-volatile. Also, what kind of devices can act as both input and output. Also, you have CPU. What is the difference between CPU and GPU? That's just your exercise, a very simple assignment for today because this is just introduction class. Okay, so you can see the diagram, the scheme here I've prepared for you. You can also relate this picture with the previous slide descriptions, right? Okay, so I think okay, so here is a little inspiration for you today. So Jimmy Johnson once said the difference between ordinary and extraordinary people is that little extra. So why don't you add that little extra time, little extra effort to make your ordinary self to be extraordinary? Okay, and yeah, that's all of the lesson for today. This is just introduction. We have maybe thousands or even millions of videos waiting you. And thanks for watching so far, following with me. Here is what you should do after this. Subscribe to this channel if you haven't. Give a like to every video, this one and upcoming videos. Comment about your thought and share this video to your friend. Yeah. Also, my computer science class and robotics will be on Monday every week. So keep watching and be thoughtful. Goodbye. See you.